David,
Yeah.
what made you build a cloud?
Oh, well, there was no cloud I wanted to use, so I have to go build our own. It's a short story. The longer story is my co-founder and I had spent quite a while exploring the AI product space, looking for things we could build around, sort of code generation. And this was pre-Claude code showing up and actually working. And so we spent a while prototyping products, including we started on an agent-like product, as you would call it today, in the pre-Claude code world. And we spent a lot of time on isolation machinery. And so we started with container isolation systems so that whenever you asked it to do something, it would copy your Git repo into a fresh container. It would do the work there. It would pull Git commits back out onto a branch on your Git repository. This was called Sketch. And it was a ton of fun. And then, a bunch of other agents showed up and were easier to use because obviously the user interface to ours was Git, which was, if every time you typed in a prompt, you then ran a bunch of Git commands to get into a specialized branch where the results were, it was a tricky thing to use. But what we learned from building all of that is we really liked isolating agents. They work a lot better in some kind of universe of their own. And we built a lot of machinery for hosting that in the cloud. And we realized that machinery was actually the most interesting thing we built. It was a surprisingly hard to spin up a machine in the cloud that did these things today. So we thought we'd explore turning that into a product. And so we kept following that path, and now we're at a path where we needed our own computers to get the shape of the machine right. We needed our own DNS to get DNS names in fast enough, given the fast startup time of the things. And before you know it, you've built a cloud.
That's a cool story. But I was waiting to ask you more about Sketch. It was called right before Shelly.
Yeah.
The Sketch thing. So first, what's wrong with using Docker?
Yeah, we started with Docker, and it worked pretty well. It worked pretty well for our local development. We designed it around our own needs, and we thought this is great. And containers are isolated enough, we said to ourselves. Where it went wrong, it came in two forms. First is, if you think about it as a development environment, we took it to companies to try. We would get their engineering teams to try using it as part of their development cycle. And the first thing they do is try running their test suites from their CI, in there. And you really want that with agents, right? You want ask it to do a thing and then have it be able to run all of the tests and start the server and try it, because that feedback loop makes agents really good at their job. Otherwise, you have to sit there in the middle constantly telling us no, the test failed, no, the test failed. And every company we took it to would run into issues with the containers. Container is not a well-defined term, right? Even in the Docker universe, there's a whole set of capabilities you can assign to your container, which is exactly how the C groups are getting sliced up under the hood to build your isolation environment on Linux. But people's test suites would include using Docker Compose to bring up some servers in the middle of the tests. And you can't use Docker Compose inside Docker, for example. And so every company we went to, when we would go and fix a series of these issues, and then we'd take it to the next company and try it with them. And each company we tried would find new things that didn't fit inside a container. And we realized these things are never quite the right shape, and they're never quite powerful enough. And what we actually need is a computer that they can run these things on that looks like the computers people actually develop on, which means, it needs to be a VM. And if your tests need to create a network interface, let them create a network interface. Give them root, let them do whatever they have to do. And as soon as you start saying that, containers don't really work at all. You really need the proper isolation of a VM to make it happen. And so that was the first big thing that got us there, is we wanted to be able to run all of these test suites. It's we ran into test suites that install K3S as part of the setup. Okay, K3S has to work. Again, it doesn't work inside even a gvisor setup. It doesn't work. So the second thing that we ran into is we discovered we really liked long-running VMs or long-running environments separate from a single session. And we realized there was actually a whole lot of software where we have a very different life cycle for developing it, where we were just treating dev as prod. And so we kept the thing around, and we would start using it, and it was the actual product. There was no deploy phase where we put it somewhere else. The development environment with the agent was good enough, and
so that's more for that's more for toy projects, right? This dev as prod type of thing.
Yeah, we used to, so going back in time 25 years, we used to develop in prod a lot, actually, and like part of this was a lack of modern best practices, but you would go into the CGI bin directory and you'd edit the Perl script that's right in there, and you'd just do it live, and you'd hit save, and the next reload of the Apache server would run the next script. Then we had, and like this was not just a Perl thing, right? Like in the Microsoft universe, they had active server pages, which was like this. You'd edit the .asp file, it would auto recompile next load. Java copied all that with Java server pages. There were these whole universes of like, we develop live. And it worked really well, actually, for some things. And it worked really terribly for other things, which is why we stopped doing that. The set of software you want to develop in prod shrunk to nearly zero from back then to 2025. And now that we have agents that can develop live for you, the sort of the central thesis is the set of software that you want to develop directly is actually no longer zero. There's some things you want to do that way.
That's a good point. You brought back a memory of mine. I did this thing in prod in 2018 with Ruby. I was working for a payments company back then, and we would run these nightly payment reconciliation scripts that would basically read the DB and format it in some sort of document for some payment provider that would expect it in a certain way. And we definitely did edit in prod. Yeah, when we had some minor issues, some minor bugs, some typo or something breaking Ruby, its type system would definitely sometimes edit in prod. I remember doing it. But back to the testing, because you really intrigued me there. I didn't know you could not run Docker Compose in a Docker container, although probably makes sense. Well, are these system tests we're talking about that are running all of these Docker containers?
I've never been very good with the ontology of tests, as in like, is it an integration test or an end-to-end test or a system test or a unit test? I've never been very good at categorizing them. To me, there are tests, and I run them for my software. And I like to, it's very good when you just test a small piece of your code, because then it's clear what fails when it does. But it's also good when your test actually tests the real database and the end-to-end nature of things. Right. And these companies piled all the, they basically had a CI pipeline of some sort that would run everything. And you really want to give an agent the freedom to run whatever tests it thinks are appropriate for the problem. And sometimes it's all of the tests. So these were probably larger tests that were actually running real subsystems. I can't remember the details of some of their compose files, but a classic thing to do in a compose file is to start a Postgres and then connect to the Postgres. And that's actually super sensible. Like mocking out your Postgres in a test is just asking for you to miss some subtlety of how some SQL statement is parsed because you used a not quite Postgres. And so there's, I'm a big fan of doing things like that generally. I think tests should be large enough that you don't fall into traps like that. So I'm quite fond of it all. From a technical perspective, I think Docker Compose couldn't start in a Docker container, and this is actually worth someone checking me on, I think Docker Compose does its DNS names by doing something interesting. It intercepts the DNS packets on the network interface, and it uses some Linux API to do that. And I think that is not always available inside Docker. And Docker in Docker is also generally pretty tricky. It's a theoretical thing that can work, and in practice, I think it gets caught on a lot of subtleties of nesting C groups.
Interesting. Yeah, I mean, my understanding of system tests is, however, it's some sort of end-to-end test that spins up the system as realistically as possible. And under my experience, at least, you wouldn't usually run these in a PR type of environment. Maybe it runs as part of the CI for the PR, but usually I think it runs on the main branch, let's say nightly. Which you bring up a good point that you probably do want agents to run these things now that they can really just drive the whole process autonomously. And it's probably something that's missing today, because I guess the usual workflow today with, let's say, Cloud Code is, you run, it iterates on the code, it runs the local tests, which are probably the system tests, maybe some integration tests, and then puts out a PR. And anything that's a little bit more demanding from resources, it probably doesn't run. When I used to work at Confluent, we were developing Apache Kafka, and all the tests on that project would take at least 2 hours on a good CPU.
Wow. Yeah,
and on my MacBook, especially when the MacBook got a little bit older, let's say it was 3 years old or something, when I ran the tests, the computer was barely usable. Like even Zoom was lagging. So I really didn't want to run tests locally most of the time unless I had to. And not to mention, imagine having 3-4 agents running their own set of tests, developing separate branches that would be completely unusable. So there's probably something to be said about being able to outsource the CPU to run the tests and also run the AI agent loop.
Yeah, I mean, I've worked on a bunch of teams in my career with very different sort of test setups. I've seen tests that take hours that run once a day. I've seen, test suites that take minutes. I'm a big believer in test as much as you can, as quickly as you can. So for example, exe.dev doesn't have a nightly test suite setup. We have the tests we run every time we push to main, and those tests spin up at this point probably thousands of VMs in the process. And if you try to run them on your laptop, you have to run them in a VM, and so then it's all nested VMs, assuming you're working on a Mac, that is, because you need a Linux base for all of our infrastructure. And it might take 10 minutes, which is why we now have a stack of very large computers in the cloud that we use for tests, and so the tests get immediately shipped off your laptop if you're working locally. And honestly, I basically don't work locally anymore. I work inside exe.dev VMs. But I believe our test suite currently takes about 100 seconds. That's sort of our magic number. And we just shard it out and use enormous computers to get it done as quickly as possible, because I really don't like waking up in the morning to find, middle of yesterday I broke some tests and now I know about it. I want my development loops to be as tight as possible. And I think that is a lot of work. Like, you really have to commit to building environments like that, and it consumes a lot of engineering time. And it's ongoing engineering time, right? Because as you work, you add tests and everything gets slower, and it's very painful. But it's a philosophy that works really well with agents, because it gives them all of the tools to know to have confidence in their work. Interesting
point. But then you said, so I'm trying to wrap my head around Access so far. So you've said that the motivation mainly was to make it AI agent friendly for development purposes. Is that a correct take?
That's where we started, yeah. And one of our theses is what is AI friendly is whatever is developer friendly. And there's a kind of mechanism here, which, I'll posit a mechanism, which is that the models we use in agents are trained on developers. So just transcripts of sessions of developers driving agents and using tools that is used to train them. And so they're very good at doing things the way we do them. And so environments that are good for us are good for them. And if they have to spend a quarter of their context window reading the docs to figure out how to use the cloud API to list the VMs that are currently running, which, some cloud APIs are not trivial, then that's bad for agents. And, we knew it was bad for us as developers, right? I don't remember the commands for listing my VMs on AWS, right? It's like 4 lines long. I have it in a shell script somewhere. Yep. JQ is involved. I have to pass some JSON to make it work. It's involved. And we've always just okay, that's bad for me, but I put it in a shell script, I'll stop thinking about it. But our agents think about that stuff every day using those systems, and it burns valuable context window that they can't use for solving our problems. And so that's our thesis, is we should build whatever's best for developers. And, I think traditionally clouds have not been built to be what's best for developers, because I don't think developers buy large resources in clouds. I think if you have a $100 million contract you're negotiating for an enterprise, you negotiate it based on who gives you the most CPUs for the fewest dollars. And if your engineers have to add 2 lines to the command they use to ls, no one cares traditionally. Now, if we want to make our agents work really well, we do care suddenly.
Yeah, I remember Azure's CLI was probably the most ridiculous. I just remember having the longest commands to run there ever. But then again, I would ask you, what's wrong with modern clouds? So, okay, let's say we burn a little bit more tokens, the APIs are a little harder to understand. I'm sure the agents, well, I'm not sure, but they must know it, because presumably they've been trained on them quite a lot. And even if they do fail right now, intermittently, I guess that might get fixed as the models improve. But fundamentally, what do you think is lacking from current clouds? Because it's quite the endeavor to build your own cloud.
Yeah, I mean, I think an agent can figure it out, right? You absolutely can figure out any cloud with an agent, and there's an argument to be said for like, we'll just throw endless amounts of tokens at the problem, and then it doesn't matter if all of the underlying stuff is no good. The question is about token efficiency, and in a sense that could be dollars. And I'm not actually particularly interested in that because I don't know where that's going to land. Actually, like the first chips really designed for LLMs are busy taping out right now, and we'll see at the end of this year. Every chip we have today that's designed for LLMs was actually designed for 10 other projects, and it's some sort of amalgam. It takes a long time to build a chip, and so like how expensive tokens are going to be in 2 or 3 years is completely unknown to me. How big a model's going to get, how sparse will they get, how much compute will be involved. It's a mystery. But what is clear today right now is models have pretty limited context windows, even these million token context windows, which never really work. Like you never really want to get beyond halfway through the token window, the context window. Every token that you're just constantly wasting doing something is eating that context window, and that's intelligence that is no longer being used to solve your problem. And I see this driving agents all the time, right? If they get distracted trying to solve some inane problem in, the way the test was laid out makes it very hard for them to figure out a problem, then they'll lose track of the bigger issue I was trying to solve around. The last couple of days I've been working on spam detection machinery, which gets pretty subtle, and it's very easy to lose track of as a human, and it turns out it's very easy to lose track of as an agent too. Like they constantly go off and get distracted. But every second spent dealing with a cloud is a second not spent solving the real problem, and more importantly, is distracting you from that problem. And maybe there are technical solutions to that. Maybe I've seen a lot of experiments with sub-agents where they spin themselves out. So they don't burn main context window. Maybe someone will solve this problem, and suddenly that thesis won't hold. But I haven't seen a solution yet.
Is that the main thesis, though?
I mean, the main thesis, that like I said, it was in 2 parts, right? And there's this thesis of we can build something that's better for developers and thus better for agents is true. But then there's the other side of it, which is the environment developers want to work in looks a little different than it used to. And this is the environment of I want a VM to come up to run my experiment in, and I want it to have TLS on it automatically. And I want it to have an IAM proxy in front of it automatically. Whereas if I start an EC2 instance today, it's immediately dropped onto the internet with some port filtering in front of it. Which is not at all what I want. I don't want the SSH exposed directly to the internet. And I want the web server only accessible to me and my team. And that sort of machinery, that's the development environment I want. And it's hard to come by. There are these people on the internet who love telling people to use VPSs to solve problems. I'm actually a big fan of that because I think they understand something about programming that is kind of lost when you get too deep into managing complex clouds.
Yeah.
But they also have a list of things you should do the moment you start your VPS. It's 30 things long. And one way you could look at exe.dev is what if we just did all that stuff for you out of the box, so that it just worked. So
that is good. I think there is space for that. We are seeing more. Talk about Headster on Twitter and everywhere. Mm-hmm. I think there is something to be said about having your own basically machine. Now that you have AI agents, you've democratized a lot of that operational knowledge to AI, and I think it probably could be outsourced for at least the toy projects. I tried exe.dev. I love it. I think you've done really well on the UX and the sign-up UX and the usability UX. I uploaded my own project there, hosted in 0 time. I don't know if everybody watching this knows how it sort of works, but as a TLDR, I would say you do have your own proxy in front of the machine, which somehow automatically logs me in when I'm to my browser. Let's say if I try to open the VPS on my browser, because I'm logged into your website, it opens the whatever I'm exporting, whatever port I'm exporting. Let's say some web server I vibe coded. Whereas if I open it on another browser, it doesn't. These sort of things are very useful for sure. And where I thought you may see use, or where it might be cool, is I imagine that nowadays in this AI world we're living in, where I see companies adopting AI coding overnight and spending millions on tokens. And people, I feel like product managers are changing their roles, and they're just their workflow now is like demo something instead of actually writing up requirements and ideas. And I feel like basically the amount of, for lack of a better word, toy projects or projects that are some sort of demo or showcase or a trial of something have exploded. And I think you're right that there's not a very easy way. If I vibe code something today, how do I show it to my friend? How do I show it to my teammate? How do I show it to my whole team? It's quite a lot of work.
Yeah. That's one way I like to describe the pricing model of exe.dev is I used to have an Apple Note. Actually, I had a whole series because they would get long, and then I'd make a new one with like a bunch of bullet points in it, and I was like one-liners of things I wish I could build. Because for everything I build, there's like 10 things I wish I could build, and I don't. There's always way too much stuff to build, which is why I like agents, right? They let me build a bit more stuff. And the idea in my mind is like, well, instead of writing a one-liner into an Apple Note as I'm walking down the street, paste it into exe.dev/new, and some of the time the thing I want actually appears, or very close to. And it's like maybe it's 25% of the time. Then the rest of the time the agent goes off the rails and doesn't understand at all what I was trying to build. But it's that dream of like, let's just see if we can build the software off the bat. Again, the set of software you can build that way is no longer zero. It's and like most things, it still doesn't work, but it's improving. And that to make that work, like on like a Hetzner style system. I would have two options. I could either, for each one of these like one-liners, I could go and buy a new piece of machinery on Hetzner. I could pay some money. Or I could take a Hetzner box and I could install Docker on it and carefully divide it into containers, and I could install a reverse proxy that like maps various domain names into it. And that machinery we're describing of like splitting up a Hetzner box, that's exe.dev basically. Like that's its whole purpose. And this is a very weird sort of economist way to pitch a cloud, but like the goal is that the marginal cost of starting a virtual machine on exe.dev is zero, because you've purchased compute resources from us. You bought some amount of CPU and RAM, and then in that you run as many VMs as you like, and they share those resources. And so you've got 10 ideas today, you create 10 VMs, you look at 7 or 8 of them and they're terrible, you never look at them again, and like 2 of them you keep poking around occasionally, and they consume almost no resources almost all the time except when you're looking at them, so it's fine. So that's kind of the pitch.
That's a good pitch. I do like that model. I haven't seen it before. It seems like today if you buy a VM, it has to have some minimum amount of vCPUs, and as you say, a lot of projects maybe they require 1 vCPU for 30 minutes today, maybe they don't for the next 23 hours. I really like that split. I've never thought about it too much. I think you're right. You could potentially do the same thing in a Hetzner box or an AWS EC2 box, but there's still a lot of things to set up and build. It's pretty bespoke, right? To split it up by containers, you have to run the proxy. Yeah.
It's actually much harder on EC2 because I don't think they allow nested virtualization, and they're already a layer in. Whereas on a Hetzner box, you could buy a bare metal box from Hetzner, right? And you don't even have to use nested virtualization, which is great. So you could set up a VMMs, you could get Firecracker running, and all this stuff. You can have a lot of fun on those things. And look, I'm all for having fun, right? Build stuff. But also I like things that are easy and just work. And
95% of people do not want that. I saw some comments on Hacker News saying that, technically you could do it, and if you want to go ahead, but I'm sure 95% of people don't want to deal with that at all. So with Exe then, are you running your own boxes, or are you running on top of, let's say, the AWS?
Yeah, we actually started on AWS. We started with metal boxes on AWS, and we did that for expediency. It's a great thing about the cloud is there's resources on tap. If I need 5 machines from AWS, they don't even blink. You just have 5 machines. It's great. I don't want to be down on the hyperscaler clouds. Like they've achieved a scale that is astonishing, and with that they've achieved all sorts of wonderful things like that. The issues on AWS are mostly the price. It's very expensive running on AWS. When you're small, if you're very large, the deals become amazing. But we're not even big enough yet to think about great deals like that. So we had an inherent price push towards doing something else, and that's when we started approaching. There are sort of white glove services for servers running in data centers, and so we started there, getting our machines racked outside the hyperscalers, and now we're talking to people. We're busy building some racks of machines, and the advantages beyond price. There are kind of two. Well, one is also a price advantage around networking, which is that the clouds have very expensive networking. And you don't really realize how expensive it is until you get outside a cloud and zeros disappear from the prices and you're like, wow, that's something. And so, we want to pass on as much of that as we can to our users. Our prices are actually still pretty high by comparison because, we're trying to build some interesting sort of global anycast machinery. But if we can make prices cheaper, we will. The second thing is the shape of machines. And it's we think there's especially for dev environments, there are machines that are kind of hard to do on clouds today that are really interesting, that are actually easier to do if you rack your own machines. And so the big thing here is around disk. So by default, clouds don't do a lot of NVMe in machines. They want to push you to remote storage. Mm-hmm. And there's a lot of, historically this made a lot of sense. When we were using hard drives, putting hard drives over a network is no big deal at all. It took 10 milliseconds to do a seek on a hard drive. And so 1 millisecond for your Ethernet round trip time is fine. Switching to SSDs was an issue though, because now the seek time is 10 microseconds and you have a 1 millisecond Ethernet seek time. And so it's, the remoteness starts to dominate the random reads and writes, which is no good. And so, they have some instances with NVMe in them, but they're shaped for very specific needs. And the big need is running traditional databases. And you can really see this in the layout of these things. If you start, a Postgres cluster on big metal specialized instances on AWS, you start a primary and 2 replicas, say, or 3 replicas. One of them fails, the primary fails, you fail over to a replica, you bring up a new machine, and then you spend the next 8 to 10 hours filling, hundreds of terabytes of data into its NVMe's. That's fine. It works really well, actually. The product's good. But one of the interesting things about it is if a machine in AWS has a disk failure, they fail you over to another machine. One disk failure means all of your NVMe's are wiped and you have to restore from remote, which takes hours because these are large NVMe's. And that's actually not a good model for us at all. A better model for us is to put a RAID 5-like setup on NVMe's so that if a disk fails, an ops person can swap the disk out and the machine keeps running. Rather than on one disk failure, we have to swap everyone over to another machine and run in a degraded mode from remote storage for 8 hours while we fill the NVMe.
I see what you mean. You're talking, it fails all the hard drives, you mean, across users. Is that what you're saying?
Yeah, if we run a machine with 10 NVMe in it, and a physical drive fails, right, you can keep the machine running and have an ops person swap the drive out and bring the RAID back up while it's running.
Because from a single user perspective, let's say you're on AWS, if your disk fails, it's just one EC2 instance disk has failed for you, right?
Yeah, if you had an EC2 instance and it has 10 disks in it, like one of these big instances.
Oh, okay.
Yeah, and one of the disks fails, they fail you over to another EC2 instance. All your disks are gone.
No way.
It's fine for your traditional Postgres replica because you just bring it up from another, and you get the machine back instantly, which is really nice. You don't wait for an ops person. Right. So it's a fine model for the cases they run, but it doesn't work for the cases we run. And there's very few machines on AWS that have these big NVMe on them. Most people use remote storage, and the problem there is the IOPS from the long Ethernet turnaround. And I don't know if you've ever seen this.
The price.
Sorry?
And the price too.
Yeah, if you want 200,000 IOPS on an EC2 instance, you pay $20,000 a month. It's expensive.
You pay a lot, yeah.
Yeah, and it's not unreasonable that it costs that much because it's actually really hard achieving those IOPS over a network. It's a technically hard thing you've asked for. But it's kind of weird, right? Because my laptop has 500,000 IOPS. And so you have this odd experience of you write software locally, it's fast and good. You ship it to the cloud, it's slow. What's going on?
Yeah, and not only that, SSD and hard drive prices have been falling off a cliff in the last 20 years, 15 years, 10 years.
Yeah, with an uptick in the last 12, unfortunately. But yeah, it's yeah, and there's a bit of path dependence. Like they built those clouds around hard drives, and then redesigning them around SSDs is hard. There's an inherent advantage to the cloud providers in having all of the disks be remote, which is if you think about all the instance types and all the different dimensions of the instance types, like for every instance type, there's the general case, the network optimized, the CPU optimized, the RAM optimized, and like there's all these variations. You'd have the same problem if you started using local disk for everything, where for each one of those, you'd have the one with a lot of local disk and the one with very little local disk.
Yeah.
And so you add an entire dimension to the SKUs they sell, and they already have a lot of instance types. And so it becomes a management, the logistics of it would be terrible for a cloud. We think it's worth paying that logistics price, the small scale, having a lot of NVMe, because we think we can build a better product doing it.
I think especially with AI should help you choose between these CQs, right? You should be able to manage a higher load that way. Like the cognitive load of, okay, which CQ do I choose out of these, let's say 1,000?
Oh, for the users, absolutely. Yeah, I mean, that's the AIs are great at that. They're great at building spreadsheets for you. From AWS's perspective, they have to manage all those different machines. They have to figure out how many to buy of each one. Like that's a hard problem.
Yeah, that's true. But from that point of view, I mean, there's virtual machines, right? So they presumably buy other machines that they virtualize on top of. So they don't buy all the VMs, CQs. So. Yeah,
I mean, I think your problem is, from their perspective, is there are some customers who want 256 vCPUs and a terabyte of RAM and 100 gigabytes of disk. Like that's what they want. Mm-hmm. And if you've gone and built a bunch of machines where instead it's 10 terabytes of disk in, now what do you do with the rest? And you can expose it remotely over the network, and that's kind of the great thing about remote disk. But if you don't, it's wasted, and then you have to charge them for it. Yeah. And so this is why the many instance types problem, and then the many kinds of machines in your data center. They have real hard problems.
I get it. Yeah, it basically removes one dimension from their balancing problem.
Yeah, that's right.
Which can be a big effect actually at scale.
For them, yeah, it doesn't matter to us as users, right? We just want the thing that works.
But what you mentioned about price is super important too. This notion where you get a bad deal if you're small scale, medium scale. If you're large scale, then you can negotiate and get the prices down. You're presumably talking about those. There was a specific word for it, I forgot the name, but these negotiations where they give you a discount on whatever thing you're buying. They can be very large discounts. Unfortunately, I think all of them are under NDA, so there's almost no public information, but I've heard cases where you can get, let's say, networking discounted up to 90%.
Yeah, I don't have any data on the sorts of discounts you can get, but I know they have the margins to give the discounts. And the simple mechanics of large-scale vendor purchases mean those discounts have to exist because, if you spend $100 million a year on cloud, and you're on Azure today, and then you go to GCP and say, "Hey, can you beat this price?" They will, because they'll want you as a customer. And so you have the negotiation leverage if you're willing to move clouds to get the discounts. And so presumably, and this is the same as buying stuff at large scale from any vendor. And so they must give out great discounts to very large customers. We can just infer it from.
And another topic on the costing is, I think the last 2 years I kind of saw this trend of people moving away from the cloud for price purposes. I think DHH was one talking about this very publicly. And other people agreed as well, because I think we've reached this tipping point where the cloud is just too expensive for what you're buying. As the hardware keeps growing in capability and basically the price of, let's say, a vCPU decreasing, the cloud prices, I don't see them moving at all. And
yeah, that's a good question. I mean, I don't actually know the general case, like. Yeah. So like DHH, I haven't read his things, but I assume he spends like single-digit millions on a cloud per year.
I think 2 million they spend.
Yeah, I don't think that's enough money to get a good discount out of a cloud. Like they're just not going to do it. And so he's the perfect example of that sort of lost in the middle company, that could be served by someone who wants to build for that without the crazy margins. And so that in a sense that's the ideal place for a business like exe.dev to get to. I think we were a long way from being able to help him, but that's the dream.
And the main pushback I see when I talked about this was that AWS gives you all of these services and all of these auto scaling and auto restart or whatever else. And I think that's a little bit overplayed. And I have my own opinions, but I want to hear what you think about this.
Yeah, I agree with you. I think it's overplayed. I would say the one magic thing AWS has that they really do have is they've always got another computer.
Right.
Like whatever's going on, there's another computer. It's on tap, and that's really as a person who's busy racking machines and buying them, I'm like, oh, I need another computer. Cool, 6 weeks lead time. It's a radically different experience when you press the yes button and 6 weeks pops up instead of a 30-second start time. So huge credit to AWS for building something like that. It's an immensely hard problem. But beyond that, they if you go to their website, there's 800 services appear, right? Almost none of those are useful to me, and they've become less and less useful. It's mostly a list of things that people thought were useful 5 years ago. And the few that are useful are very easy to do now with agents in a variety of ways in the open source stacks we have. There's a couple that are great, and I really admire.
Yeah, the cloud UX is ridiculous. The UIs are just ridiculous to navigate through. And, agents experience the same thing, as you say. And the CLIs and the APIs, I guess they're sort of a byproduct from this overcomplication.
Yeah, but if you look at all the managed database machinery on AWS, I don't think I want to use any of their managed database products. Mostly because they're the wrong shape for the problems I have. I think if I had to run a Postgres on AWS today for a company, and I had to just use AWS, I would just do it myself. I wouldn't use RDS. I wouldn't use Aurora, any of those things.
I think you're in the minority here.
I think I probably am in the minority, but I think I've also seen RDS fail catastrophically.
Yeah.
Which until you've experienced, you don't really appreciate the horror of it. I would love someone to manage my database for me. I don't think those products are the answer, though. I think there are other products out there that might be. I'm very happy with the idea of managing my database. I just don't think they have or someone managing it for me. I just don't think they have the products for me. And if I look through their catalog, there are a couple of things they do really well that I would not want to do myself. They have an email sending service, for example. Mm-hmm. Sending email well is actually really hard and requires a lot of care and attention to the quality of your IP addresses, how other vendors are talking to you. It's a big data problem. And I think the Amazon service that does really well, and I would happily be a customer of it. In fact, maybe I should be. I should go investigate it. It's classically there's S3, which Amazon do quite well, which has always been a funny shape to me. I've never been a huge fan of it, but I have to admire the fact it works, and I totally see why people use it. So.
Yeah, S3 is an engineering marvel. Yeah, I don't know about people. I think a lot of people don't want to host their own database and their own data infra. Partly psychological fear of so complex, partly being able to point the blame button at somebody, I think. Avoiding responsibility for data infra that costs your business millions if it goes down, I think is another appreciated aspect. I worked for Confluent, which was a managed Kafka offering, so Kafka SaaS. And I saw a lot of this. A lot of people do want you to run their Kafka. And all of these vendors, what they do day in and day out is just they market how hard open source is to run and how hard it is to manage. When in reality, there's nothing hard about it. There is a learning curve where you need to know what the configs mean and you need to know how the service works and etc. But there's nothing fundamentally difficult about the software.
Yeah, I do. I agree with you, and I'm actually really curious what agents are going to do to that in the future. I am, using agents to crash course myself and how a system works is extraordinarily effective. And this comes, of course, I've got 30 years of background in a bunch of systems, and so learning the next system isn't too hard. Mm-hmm. But it's amazing, right? I've never actually run Kafka myself, but how long would it take me to figure it out with an agent? Maybe if I sat down and worked hard for a week, I could, I would understand a lot of its failure modes and be confident to run it myself. That wouldn't have been true 5 years ago.
Yeah, definitely. Just the ability, it democratizes knowledge like nothing else, because the knowledge of how to run Kafka is somewhere out there in the vast internet. There are multiple articles. It's just that you need somebody to go over all of them. And humans usually do this by spending 5 years in the industry and just reading whatever they see. But an agent can pull it, in an hour.
Yeah, I mean, back to RDS, just because, again, I've seen it fail. Like, the scary thing about RDS is they're running Postgres for you, but you don't get direct access to the Postgres. So there's all sorts of failure modes where you know exactly there's a button you could push to go and fix it, but you can't. And again, if you're small and you email them, some hours later they might look at it. It's a very nasty setup. And again, I agree that there's a great idea of letting someone else manage it for me. But now that I can go on the internet with the help of agents and figure out potential solutions to Postgres, the idea that I couldn't get to my Postgres is terrifying. Like, I want to fix it. So,
yeah, to play devil's advocate also, I mean, there is a sort of network effect in SaaS providers where if you're a SaaS provider and you have thousands of customers and they hit the same issue, eventually you develop some proprietary solutions that the open source never sees. And then you might have some issues that would have been a problem with the open source that are not a problem to you because your automated system fixed it already. So that is one thing that, credit to SaaS if done right. But to your point, and I was going to bring the same point, is that AI changes this completely. I don't know where our AI SREs are, but I expect to see products like this in the not too distant future, because fundamentally I think it's a very simple problem to solve. There's a lot of pattern matching in like, okay, the log says this, my disk is full. At least I know what to do. I know what the runbook kind of looks like. Maybe a human can approve me running these commands, but I really think we're going to see improvements. And to that point, it's a good time to segue Shelly, which is your AI agent in exe, which I did a demo. I logged into a VM, and I said to Shelly, I just said, hey, build me a Kafka cluster, give me Grafana, give me a nice UI, give me a schema registry, and send a message or something like that, or give me a UI for these things. And like traditionally, this would have taken me as a human probably 2 hours to do, because the route is open Kafka, read the docs, read the quick start. Okay, then find the schema registry component I need to open. It's a separate component, not part of the open source project. Open the GitHub, follow the README, find the UI. There are 20 UIs to choose from for Kafka. Pick one, follow the README, follow the installation, set up everything, create a Docker compose or something, spend 30 minutes trialing and erroring that out as it fails to deploy. And eventually I got it. Shelly, or should I say Claude, or both, did it in under 15 minutes. I actually demoed it in a video. That blew my mind. That's a major time saver. And it's an example of what I'm saying, that ops should and are getting so much simpler with AI. Do you guys use anything like this internally?
Oh, I mean, so it's, there's a constant tension between doing a better job in production because you put an agent there, and the danger of putting an agent in production. The only time I've ever actually deployed an agent in production was when we launched back in just around it was just around Christmas time. It was just after Christmas. We just had it open so anyone could just use it directly. And we immediately got a lot of spam and abuse. It was a whole lot of... there was some Bitcoin miners, but it was mostly DDoS clients and other really nasty stuff. We had a whole bunch of people... We had a spammer signing up really regularly, creating accounts every few seconds. And somehow they were wrecking our machines. And I thought to myself, well, they're creating accounts every few seconds, so I created another production instance. Because this was back when we were on AWS. I pushed the on button, got another machine, loaded it up with spammer accounts, watched the machine start to flail. Then I installed a command line agent directly on it and gave it root. And I was like, I'm willing to do this because it's just spam VMs. Like, I'm not putting anyone's machinery at risk. And I said, look, what's going on? Why is this having such a detrimental? Why do these VMs, why are their network behavior not isolated from the other ones? And it went and examined a whole lot of syscall machinery I didn't know about. There's always something new to learn about Linux, right? And it came back with an answer really quickly about an IP tables misconfiguration I'd made in the system, where I thought I was carefully restricting VM's ability to influence the contract table, but I got the interfaces wrong. And so they were able to collapse this table in the host in the host system, as networking configuration, and like ruin the day of all of the VMs next to it. So like as soon as I knew this, it's like a one-line fix, and deployed it and like all the other machines, and then like cut the spammers off and deleted all their VMs. But I didn't know what to look for. Like we were delving into some very obscure part of the Linux kernel that would have taken me many hours of research, and here I was fighting a production issue, and I was in Australia at the time. It was 2 a.m. and no one else was online, and so like the fact that an agent just showed up and solved the problem for me was it's one of those experiences like the once it happens to you, you're like, wow, okay, I'm never going back. Like I need this tool in my pocket to solve problems. So yeah, the magic for me of the AI SRE, which again doesn't really exist yet, because what AI are you going to drop into production and like really risk user data with? I wouldn't. You can't do it on a real machine because there's risk of user data egress. Exfil, you can't do that. But at the same time, they have all this esoteric knowledge about systems that is extraordinarily hard to come by, and can solve problems so quickly. Like we have to figure this out. So. We
do, yeah, we definitely do. I guess as a naive implementation could be a read-only version where, let's say, you don't deploy it to the VM, but you have all of your VM telemetry and data ship out to some system which the AI can then analyze or some. So I guess the way to happen is, well, before production we have the toy projects, which is, let's say, my account on exe.dev. I run some toy websites there. I'm happy to give the AI everything there.
Yes, that's exactly. Yes, me too.
As I said, this isolation lets me like run the AI as much as it can. Let it break everything. I'll create a new VM. I don't care. So that already proves the strength. This is production for me for something that's not super important. And then I guess we'll get this top-down effect where first we use it internally. First we use it on our own devices, which is, let's say, my MacBook, which is probably backwards now that I think of it, but I think that's how the adoption started. Everyone installed Cloud Code locally. Mm-hmm. Then we're going to start using them externally, let's say some dev machines like exe or AWS or whatever. And then eventually maybe it reaches its way to dev staging, maybe production, I don't know, in some very contained form. But
yeah, I think you've hit a couple of really good points there. First is, we all installed Claude on our laptops, and I can't imagine running an agent directly on my laptop. Now it has the keys to everything. Like it's the last place I'll put an agent. But then, in production, you're right. Again, all of that software that I'm willing to isolate and do the whole dev equals prod thing for. Like, I'm very happy to let an agent have root and like edit some systemd files and change some cgroup configs. Who cares? It's like. I have snapshot, actually, this is a feature that we're about to launch for XCD. We're just trying to get the UI right. Like, we actually have snapshot backups of the VMs. And like, to me, the big trick to dev equals prod is the big rollback button that you click and you just go back to a snapshot from a few minutes ago. Because, if it deletes your production database, where your production database is a spreadsheet that 5 people use, like, that's fine, right? It's a perfectly good control system for agents. All of that seems straightforward to me. The actual AI SRE is the really hard one, and I agree. Read only sounds good, but there's like 2 sides to this that's really challenging. The first is like read only still only gives it some of its ability. Like, it's actually really useful to let an agent play around a bit on a system so that it can explore and find the problem. There's some problems you can find by actually changing some sysctl settings. And the second side of this is just Simon Wilson's lethal trifecta problem of the moment your agent is sitting around with user data or any data you value, you have to cut off its internet access or else it can exfil the data.
Right.
And like, you start, and like as soon as you do that, it can't go and Google search for weird user forum posts from 20 years ago that have the solution to the problem.
But also you can't use, let's say, Claude or OpenAI, because that is from the internet, and you're potentially feeding the models with that data too.
Yeah, we do everything through a ZDR contract with Anthropic and OpenAI, and so the zero data retention contracts. And I trust contract law enough that those companies are actually not retaining and training on it. I certainly hope that turns out to be true, but they're promising it's true, and so I choose to believe them. So.
Okay, no, I just wondered if a customer has a contract with you and you have a ZDR contract with them, does that complicate things? But maybe not.
We don't store any of the sessions with Shelly. They're stored in your like local SQLite database that you control in your VM, but like we don't train on it, and like we pass everything through on those sort of standard business contracts. So,
but to your point, even editing that sysctl settings or something, I mean, even if a human does it, that's still something that's very risky, and usually you will not see it in production, right? Like at all.
That's right. I mean, that's why, I'm scared of the AI SRE doing a thing I would do, right? And like breaking the computer. I break computers all the time. So.
Yeah, no, I mean, I think we're far away from having an automated AI system. We have automated systems that we've coded up ourselves, sure. But even today, if you're in a big company and you want to do some change to production, as a human, you still probably need approval from another SRE at a minimum.
It depends on the environment and the setup, but yes, I've seen everything from SREs have to sit next to each other while they work and read each other's commands before they hit enter, to software systems that enforce that, to companies where the SRE is it's a part-time role that the programmers fill, that whoever's awake deals with the problem. Yeah, it's the world's got the world spans the spectrum.
Exactly. So there is a spectrum, and I was gonna say there's also this, like, human psychology has showed us that people will risk things for convenience. I think the best example is Tesla auto driving. Letting a robot drive your car is the most dangerous thing you can do day to day. But in practice, it works. In practice, people trust it enough to do it, and maybe they even put their hands off the wheel, even though they shouldn't. So from that perspective, from that context, I think I can imagine a fair subset of companies even YOLOing with some agents in production.
Probably, yeah. I mean, it's I mean I don't know how far we can push the robo-taxi analogy, but I've been in a few taxis, and they haven't had the best human drivers, which are a little scary. And the robo-taxis, in theory at least, all the data is centralized and studied, and you can draw good statistics over how reliable the drivers are. You don't get a robo-taxi that didn't sleep well last night, or maybe spent too long at a party or something like that. Long term, those sort of well-studied systematic models give you better results. We may not be there yet. I really have no idea what state things are in.
That's a great point with human error. It's an amazing point. You're right. The majority, well, I won't say majority, but a fair amount of SREs are not to the level you've been used to working with, because maybe you've worked at really good companies, you're in the valley, etc. Like the spectrum of SREs in the whole world, everybody running some sort of production database in every country in the world is very large. So now that you said, I think actually I can probably replace a lot more than we think.
Yeah, I mean, me being an SRE at 2 a.m. is not what you want. I'm not at my best. And so, is there a day when a machine can do a better job than me at 2 a.m. as an SRE? Absolutely. Like, I'm very excited to see me get replaced in that role. And so,
all right, well, we have a few minutes more to go. I want to ask you, is there anything you would like to share about exe, your career, or basically anything about the topics we've been talking about so far?
Oh, yeah. I mean, I'd love people to try it and give us feedback.
There's a 7-day trial, right?
There is, yeah. Most of the time, depending, again, there's a complex spam fraud model in there now. But most of the time, if you show up, you can just try it with a 7-day trial. Feedback's great. I think the thing we're most interested in right now is, what's the next thing we need to build to be more generally useful? Because we have so many things to build. We have these really long lists, and it's a big challenge for us is just prioritization. Like, do we need more sophisticated DNS control? Do we need static IP addresses that you can open arbitrary ports on? Do we need good? We have integrations. Do we need a good Slack bot integration so that you can talk to Shelly in Slack? Is what's missing a Discord integration? Just trying to answer questions like that. User feedback is great for that, to try and get to which things should we be prioritizing. And we get several pieces of feedback a day, and then I have agents help me put it into spreadsheets and try and manage it. And Again, it's a good task to try and automate because there's a lot of value in trying to be rigorous about these things. It's very easy to get the last 4 people I spoke to, the anecdotes they told me have way too much weight in my mind.
Yeah.
And I want to solve their problems immediately. If you make a spreadsheet of the last 40 people you've spoken to, you suddenly see the pattern is very different. And you're like, oh wow, it's good to be rigorous about these things. So yeah, we're very much in data collection, feature build out phase right now.
I mean, how old is the company? How old is this cloud?
Oh, I mean, we launched in December and started work on it.
So it's 6 months.
Yeah, that's right.
That's nothing. That's
there's a long way to go. But we have a very good team who are capable of building a lot of things. We have a lot of we have agents supporting us building things, which helps a lot. And we've got good foundations to build on, which is nice. Building EC2 back when they built it was extraordinarily difficult because the Linux kernel did not help you back then. Even though they were giving dedicated slices of a machine to each VM, they still had noisy neighbor problems because Linux was not good at isolation and scheduling. And in fact, there was a very early, now very big customer of Amazon who was telling me that they would start their EC2 instances and then run a little for loop in Bash on it that would just print the date every second. And then they had a outer script that would look at the dates that got printed. And if 10% more than a second was spent between each second in the date printing, so the sleep 1 actually slept 1.1, they would shut the EC2 instance down and start another one. It meant there was someone else on the machine who was using a lot of CPU, and they had a noisy neighbor. So they had to build this noisy neighbor detector in front of EC2. But the Linux kernel is so good at isolation and control now that it's so much easier to build high quality cloud-like primitives, which lets us get into building more interesting primitives precisely because of that. So yes, it's a good foundation to work from, and we have a lot to do. So
that's amazing. Well, I'm really looking forward to see what you guys built. I can't believe it's just been 6 months because the product looks very well polished. But I'm looking forward to see next year, next 2 years, next 3 years. I wish you all the best of luck, and thank you for taking your time.
Thanks, Dan. This was fun. You have a good day.